the idea of the diamagnetism and the paramagnetism. All right, so before we jump into the topic, let me show you one experiment. One Dutch and the British scientists, they have done an incredible job, and the job is that they have levitated. They just float a frog in the mid-air. I'll give all the links down below, then you can go to the YouTube and search this one. And but you can see from the video top, you can see the screenshot. The British and the Dutch scientists make frog float in the mid-air. This experiment known as the levitating frog. All right, so let me show you the experiment. As you can see, this frog is basically levitating, and the camera lens is on the top, and on the bottom there is nothing. This kind of a tunnel. The photo is being snapped from the top, and you can see that this frog is basically levitating. One insect is also levitating in the mid-air without help of anything. He's not using his wings or something like that, but he is levitating in the mid-air. Also, you can see that one flower is also levitating in the freely in the air. It's floating in the air. All right, so let me show you another experiment. This guy, what he's doing is he's holding one magnet, strong magnet, and this is permanent magnet, and he's bringing this magnet close to one liquid water column. All right, so see. So basically he's bringing one magnet close to one liquid water column, and you can see that this is strange thing is happening. This magnet and the water column, they are basically repulsing each other, or the water basically repulsing the magnet. And how can this be possible? Like, this is not a magnetic material, water, right? So how can this be, like, it can repel? So instead of water column, he is now doing this experiment with a piece of wood, and now this time also, the moment he went close to this wood started repelling, and it started moving away. This is a crazy experiment. When the moment when I see this experiment, and then I try to learn everything, what is the idea, why this is happening, and after the end of this class you will understand what is the basic idea of this particular experiment and why this is happening. Now we'll talk about the diamagnetism. All right, so yes, we'll start with diamagnetism. All right, so yes. All right, so you have to understand the very basic of the diamagnetism. You need to know the very little of the atomic chemistry. All right, so if you know the atomic chemistry, let me quickly show you the very basic idea of the atomic chemistry. If you have seen the electronic structure of the last cell of any p orbital, for example, this is the p orbital. So p orbital has 3 subcells, right? So whenever the electron enters in the p orbital, we know that the electron enters in this way: first spin up, spin up, spin up, and then spin down, right? So now, as you can see, this electron is unpaired electron, right? So this one is the unpaired electron, and this 2 is the set of pair electrons, right? So whenever you want to the pair electron, what do you mean by the pair electron and what do you mean by the unpaired electron? For example, so let's say this electron is rotating around the one atom. For example, this is the the path of the rotation of the electron around the nucleus. Now there is another electron who is also rotating around this same nucleus, and it is also covering the same path, but the rotation direction, if we look at this particular thing, let's say rotation direction, one is rotating if in this direction, another one is rotating in the opposite direction. So what do you mean by that? The radius of the path and everything is same other than the direction of the rotation for the paired electrons, right? So now when one electron is rotating, it is basically constituting the electric current. So when one electric current, let's say for example there is an electric current, and this current I is very small. Although this current is very small, this current will generate some amount of magnetic field either upward or in the downward direction, as we know that, right? For the loop 1, for example, let's say this one is the loop A and the downward is loop B. So the loop A will generate some amount of magnetic field in the upward direction, then loop B will generate some amount of the same amount of magnetic field in the downward direction, and which basically or essentially it will cancel the magnetic field for the paired electrons. All right, so you are getting my point. Ideally you can believe that. So for any given like a loop, for example, any given current carrying wire, if that is making a loop, so this is basically behave as a tiny bar magnet. Okay, so you can believe this fact also. This is also kind of a similar effect, right? So this is north pole, south pole. This is when one loop is carrying current, right? You can also expect in this way, or you can also explain in this way that the magnetic moment is in the upward direction for this one, mu1, and for this case for the downward loop, the magnetic moment in the downward direction, right? And also for this loop we can say that the magnetic moment is in this direction, right? So mu is basically represented by the magnetic moment, like electric moment. We can also we can also represent the magnetic moment by the mu, right, in this case, right? So now the point is that when one like any organic substance we are talking about, any kind of organic substance when we are talking about, so all the organic substances, they do not have the unpaired electrons, like you, like me, the wood, then the frog, and like flower, whatever we have seen in the experiment, on that particular experiment what I have showed you just in the beginning of the class. Then I have showed you that there are a couple of piece of organic atoms, we can say that organic atoms, they do not have the unpaired electrons, they have the paired electron. That means they have this kind of structure, so they do not have any magnetic moment, or in other words we can say that the magnetic moment for any organic substance is zero. So they have to show the zero magnetic moment, or in other words they do not have any magnetic property. Now, so when in the experiment we have seen that man was approaching with some magnet towards the water column. Then if we draw this diagram, for example, if this is the north pole, this is the south pole, we know that the magnetic field lines will be in this direction, right? So magnetic field lines in this direction, and so magnetic field lines is going in this direction. Now let's say for example there is one liquid column exists. Now at the border of this liquid column, maybe there are valence electron also residing. If you look very deep inside, then for example like inside of one water atom there are paired electrons, they are lying in this way, right? So we can draw two paired electrons in this manner, right? So this is one paired electrons, right? Now this is another paired electrons, right? So this is basically part of the electrons I'm drawing. Now as you can see that, so the moment when we approach towards these paired electrons, and these two electrons are carrying current in the opposite direction, so that's why the net magnetic moment for this paired electron is zero, that we know. Now when we approach with one magnetic north pole towards these paired electrons, then what will happen is that whenever this first pair electrons, for the first electrons will experience a magnetic field lines which is passing through that particular coil, then this coil will experience a current from the Faraday's law. Maybe I expect that you know what is Faraday's law, and I believe that you know what is the Lentz's law. From the Faraday's law or the Lentz's law, this is basically, we know that whenever there is any changing magnetic field lines, there will be a induced current inside of the coil. So this coil will get some amount of induced current. Let's say, for example, I is the amount of induced current that induced for the changing magnetic field which is occurring due to this magnetic north pole is approaching towards this loop, right? So whenever this happens, then this extra amount of current whatever that generates inside of the first coil, this will basically increase the amount of magnetic field, or in other words, we know that for any given coil the magnetic field B is given by B equal to we know that that is the formula is mu naught Ni by 2r, where mu naught is the magnetic permittivity of the free space, n is the number of coil, number of turns, I is the amount of current, and r is the radius of this particular circle, right? So this is, if this is the equation, then we know that with the increase of, or with the increment of the I, with the increment of the I, the magnetic field will also increase. So in the very next scenario, what we can expect is that, in the very next scenario, we can expect that this first loop, the first loop, it can increase in terms of the magnetic field. It will increase, and the loop just beside, just below the pair electron group, it will no longer be able to cancel out the net magnetic moment for the first loop, and as a result there will be a small magnetic north pole which will be introduced here, right? And as you can see, this north pole and this north pole, they will repel each other, right? And if inside of the water column there are billions of atoms, and billions of atoms has like couple of more billions of electrons, paired electrons, and each pair of electron is basically producing a tiny magnets, and these magnets, all the magnets are basically creating one north pole, and which will basically repel the north pole which is coming towards that particular paired electrons, right? This is basically the Lentz's law, right? So, and that's why we have seen that water column is repelling the incoming magnetic lines of forces. So this is the exact explanation. Now this property is called the diamagnetism, right? So this is called the diamagnetism. So now what is diamagnetism? If someone asks you, the diamagnetism is the property of any organic substance or the paired electron groups to repel the magnetic lines of force. So this is called the diamagnetism, right? So in the next class, we'll understand what is paramagnetism, and then in the very next class, we'll understand what is the ferromagnetism. All right.